find the intervals where the function is increasing and the intervals where it is decreasing. We first find the critical numbers, that is zeros of derivative. So let's find its derivative first. So derivative is 5x squared means it will be 10x plus 2x means derivative 2 plus 0. Don't have to write. Now we set the derivative 0. That is 10x plus 2 equals 0. Solve for x. Subtract 2 from both sides. Divide by 10. So x equals negative 1/5. 2 goes 5 times. So this is the critical number for this function. That means the shape of the graph changes from increasing to decreasing or decreasing to increasing. Now we need to do the sign chart or interval test. Domain of this function is all real numbers, and we got negative 1/5 somewhere, negative 1/5 here. So we got two intervals here, negative infinity through negative 1/5 and negative 1/5 through positive infinity. We pick a representative from each interval and test the sign of derivative. You can pick any number in between. Let's say x equals 0. Let's pick x equals negative 1 or negative 2 and substitute here. And we know that if the derivative is negative, then the function is decreasing, and so on. So let's plug in 0 here. If we plug in 0, we get 10 times 0 plus 2, which is 2. It's a positive. So the derivative, let me write f prime, is positive. You can write 2 or 1, doesn't matter. That means on this interval, the function is, the derivative is positive, means the function is increasing. So I can write that notation there. Let's look at it, negative 1. On this interval, negative 1, 10 times negative 1 plus 2, that's negative 10 plus 2, negative 8. So derivative is negative. First derivative negative means our function will be decreasing. So we write the answer as follows. So the function, given function is increasing on negative 1/5 through infinity, and our function is decreasing on negative infinity through negative 1/5. Final.